Bismillahirrahmanirrahim. Let us look into this example 3 of your workbook, page 253. Okay, an integral of 1 plus x squared. There is no radical there. So what method should we use to integrate? Okay. So I'm rewriting back the question. Okay, in a first glance, you might like to try using a simple u substitution. Okay, let's take the denominator 1 plus x squared to be the u. But when you differentiate and try to get rid of the x so that you can change everything in terms of a u, as you differentiate, okay, du dx is okay 2x, so du is 2x dx. So dx there, as you replace it, so dx there, as you replace, you will get du over 2x. So x there, it will become complicated, right? So x is the square root of 1 minus u minus 1 square root. You cannot split, okay, so that you are stuck, meaning you cannot use a simple u substitution this way because up to this level there are still two variables and the x are still there. You cannot integrate with two variables. So another word to say, you cannot use a simple u substitution. Okay. So for this question, we have to use trigonometric substitution. But if you can see that the form is in a form of a radical for us to substitute. So let us check whether it works for this case. Example 3, there is no radical there. And what would be the appropriate trigo substitution? So again, we are to look at the format. The form is a squared plus x squared or x squared plus a squared. So the second one. Okay, so as we compare to the format, x squared plus a squared, the appropriate trigo substitution is to set the u to be a tangent theta. So we start with that. Okay, S1 for the statement. And then we differentiate according to your formula list. The derivative of tangent theta, dx d theta, is secant square theta. Okay, so we differentiate. And then next, this has the boundary, but before that, let's look at the changes. So dx just now, we have secant square theta d theta. As for 1 plus x squared, 1, we put it 1 plus our x is tangent square. Okay, tangent square theta. Okay. So we substitute, there we get everything in terms of theta. And this part we can simplify. How to get to that part? Because we have to look at the identity. Okay, look into your formula list. In your formula list, the tangent, the Pythagorean identity, tangent square A plus 1 is secant square A. This is given in our formula list. Okay, so hence the denominator value we get, this part is secant square. Right? So and then we simplify secant square, there's a power 2 that we simplify. This is secant power 4. Let me write that. So we replace the identity secant square and then square. Okay, use identity, change it into secant square, and as we simplify, we get cut, we get 1 over secant square. Okay, currently, and 1 on secant is cosine square. Okay, so you have to leave your answer up to that level. And then what about the boundary? Let's change the boundary in terms of a theta as well. So we have x being tangent theta. For the upper boundary, when x is, he started with lower boundary. When x is 0, theta is inverse tangent 0. Tangent 0 is 0, so the theta is 0. As for the upper boundary, when the theta is inverse tangent 1, tangent angle equivalent to 1, tangent 45 degree is 1, so the angle is pi on 4. Or you just can plug in into your calculator, but try to give your answer in terms of the real number value. Okay, this value 45 is similar to pi on 4. We change the boundary. Okay, next we got this, correct? Okay, next, how do we integrate cosine square theta d theta? Okay, we have done this integral last time. Okay, look into your workbook, page 238. Why don't you look now into that workbook, page 238. Okay, if you refer to that page 238, our variable was x, so let's change it into theta. Okay, so half theta plus 1 on 4 sine 2x sine 2 theta. Right, so we got that the answer given in our workbook, and we have done it earlier. So how to get to that? Because here on how to get to the answer, basically you are supposed to use double angle formula on the working. Make sure that you show all the working until you can get to that answer of the integral. And yes, we have to put down the boundary, our boundary, because it's definite integral. Our boundary is for 0 to pi on 4. Okay, our workbook here, they are factoring the half. Okay, the half. So we have sine 2 theta, okay, on 2 plus theta. And then we are to substitute the upper boundary minus the lower boundary. Make sure that you show it. Okay, upper boundary minus the lower boundary. Replace everything in terms of the 0. There's an M1 there. And then simplify your value as exact value number. You can leave it like this, no problem. So a question like this, the long working over here, make sure that you show it. Last time we gave 3 marks, 4 marks, 5 marks. Let's say 4 marks for it, for the changing it into the half of double angle formula, and then you are supposed to use a simple substitution and integrate to get to your answer. Okay, for this part. So meaning if I am to take this as 3 marks, show your working, and that will be your answer. And then 1 mark for you to read your definite integral and simplify your answer. Let's count how many marks do this type of a question carry. So this question I gave 9 marks altogether. Okay, and you can see that yes, we are applying the Trigo substitution. We can apply Trigo substitution for this type of the question, even though we don't have a radical term there. Alright, okay, let's look at the last example. So let's discuss this question given in our workbook, page 254. We have a radical. You are only able to use the Trigo substitution provided that you are able to change this in a form of a square minus or x square minus a square, this form. Okay, and hence by Trigo substitution we set the x, in this case our x is x plus 1 equivalent to a is 2 square 2 and secant. Okay, so how do we get from this part to this part? Okay, let's recall back on the completing square. So if a simple formula of completing square, provided that the coefficient of x squared is 1. Okay, if we have a quadratic in a form of 1x squared plus bx plus c, the formula is to add and deduct back the b over 2 square. Like for this one, okay, x squared plus bx plus b on 2 plus c, okay, plus and minus. For this three portion, you can nicely factorize. It becomes a nice complete square in the form of x plus b on 2 square, and this is the constant. For example, our question is x squared plus 2x minus 3, where the b is 2. So b on 2 is 2 on 2 is 1, right? So we have plus 1, deduct that. So for these three parts, you can nicely factorize. It becomes x plus 1 square. You can check that by expanding it back, and you will get back to these three portions. And the constant in this case is the minus 4. So we get that the form of the x square, the variable square, minus the constant 2 square. You have to get this correct first. And make sure that you show the working as well. Okay, M1, A1. Let me give 2 marks there for you to get to this format. And then hence we have 2 marks just now, right? So make sure you show your work. M1, A1, okay, just now. And then by Trigo substitution, the first mark goes to what is the appropriate the substitution. We take the whole set there to become secant. The a square, the 2 square, the a is 2. The a is 2. Okay, so there's a mark there. And then from there we differentiate both sides. The x on d theta is 2 secant is secant tangent. So correct derivative. And then we are to substitute. So change everything in terms of the angle theta. So the x is 2 secant theta tangent theta, alright. And the x plus 1 square just now is 2 secant theta square minus 2 square. Okay. So this M1, substitute everything. There is no more x there. Okay, this is indefinite integral. We do not need to worry about the boundary. Okay, for this part, you need to simplify. Okay, it does not show there. Let me show it here. So basically what happened was, for you are to factorize. And since that we have multiplications of a radical, you split the radical. And secant square minus 1, you are to use identity. This is similar to, look at your formula list, secant square minus 1 is tangent square. So, get it there. There's an M1 for the identity that you used. And hence, tangent square square root, we eliminate the radical. So, we are left with tangent theta. And then you simplify, cut, you get until the secant theta. Make sure that you show the simplified form. As for the integral of a secant theta, it is given in our formula list, which is ln secant theta plus tangent theta. You can just quote the answer there. So a question like this, example 4, how many marks will it carry? So for this case, I give 8 marks. And make sure that you show step-by-step work. We do know that if m is 0, did not show it, we cannot accept your answer. Alright? Okay, so that's it for the example. Please do more questions. Refer to the class exercises. Thank you.